Welcome to Get Your FRQ On. This question is from 2007, Calculus AB. It is question number 4, and it is not calculator active. In this question, we have a particle moving along the x-axis, and there's an equation that gives its position. And in part A, we are asked to find what time t the particle is furthest to the left and to provide justification. All right, so for particle motion problems and similar type problems, the point where the particle will be furthest to the left means that it has a relative minimum. Its position function will have a relative minimum at that value of t. All right, an absolute minimum, furthest to the left. All right, well, we're given the position function x of t, that's e to the negative t sine of t, and this is only defined for values of t between 0 and 2 pi. All right, so to determine where this function has an absolute minimum, we have to find the derivative of x of t, which is negative e to the negative t times the sine of t plus e to the negative t cosine t, which we can factor out the e to the negative t, that's going to be e to the negative t times cosine t minus sine t, and again, this is only valid for values of t between 0 and 2 pi. Right? When will that be 0? Right? So x prime of t equals 0. It's never going to happen with the e to the minus t factor because e to the negative t will never be 0. So the only chance x prime of t has of being 0 is when cosine of t minus sine t is equal to 0, which would imply that cosine of t is equal to sine t. And on the interval from 0 to 2 pi, that will happen at t equals pi fourths and t equals 5 pi fourths. Right? So we have to check the endpoints and the two values of t that we just found. X of 0 would be e to the 0 times the sine of 0, which is just 1 times the sine of 0, which is 0. X of 2 pi would be e to the negative 2 pi times the sine of 2 pi, also equal to 0. X of pi fourths, which would be e to the negative pi fourths times the sine of pi fourths, which is e to the negative pi fourths times square root 2 over 2. Notice that that value is positive. And x of 5 pi fourths would be e to the minus 5 pi fourths times the sine of 5 pi fourths, which is e to the negative 5 pi fourths times negative square root 2 over 2. And notice that that is negative, and so that would represent the absolute minimum. All right? X prime of 5 pi fourths is 0, and its position function is the only one that's negative. So it has to be the point where the particle is furthest to the left. All right, so based on these results, the particle is going to be furthest to the left at t equals 5 pi fourths, since this is the only critical point for which x of t is even negative. Part B of this question, find capital letter A, a constant, such that a times x double prime of t plus x prime of t plus x of t is equal to 0. And again, noting that this is only going to be defined for values of t between 0 and 2 pi. All right, so from the question stem and the previous part, we have the position function, e to the negative t sine of t, the velocity function, x prime of t, which is e to the negative t times cosine t minus sine t. All right, by the product rule, right, x double prime of t is going to equal e to the negative t times the cosine of t minus sine t plus e to the negative t times negative sine t minus cosine t. But notice that the e to the negative t sine t's will cancel out, and we end up with just negative 2 e to the negative t times cosine t as our second derivative. So now we set up the equation, right? We're supposed to solve a times x double prime of t plus x prime of t plus x of t equals 0. So now we have all of this. We have a constant a times our second derivative plus our first derivative plus our original function has to equal 0. Notice a bunch of this stuff is going to cancel out. We're going to get e to the negative t times negative 2a cosine t plus cosine t minus sine t plus sine t. Notice the sine t's cancel out. And that is supposed to equal 0. Well, we also have a common factor of cosine t that we can factor out. All right, so e to the negative t cosine t times negative 2a plus 1. If I specifically want to know what value of a will cause this to be true, we just solve the equation negative 2a plus 1 equals 0, and a would have to equal positive 1/2.